I'm Colin. I am here as a consultant with Ownership, also a consultant at Crowdcoding. Done a bunch of things with MySQL and MariaDB, and more before that. So quick ad, want to go win something, go to the Ownership booth. So I'm going to talk about MySQL and MariaDB quite interchangeably because they really are kind of similar. The MariaDB server is more or less a fork, and it's become clearly more of a fork as releases go by, and there are new changes that are MariaDB only. Also, worth noting is that Percona server for MySQL 8 also has some added improvements over regular MySQL 8. So, anybody use Percona server? No? Anybody use MariaDB server? Anybody use MySQL 8? Okay. So breaches are really bad. So the more records you tend to have, the more your costs are going to go up for breaches. Ashley Madison was one of the famous breaches of a couple of years ago. If you know this website, maybe it was because you were planning to cheat on your partner. If you don't, good. It was a very popular data leak amongst divorce lawyers. Philippine voter data may be a bit more serious. 50 million Filipinos work overseas and they vote electronically, and their thumbprint is also recorded. This was leaked. You can get it on the dark web. With your thumbprint and all your voter data, you could go apply for loans in someone else's name. Panama Papers. This one must be extremely popular for most people in Europe because you were looking for all the tax dodgers. So maybe you know someone in the Panama Papers. Under Armour acquired MyFitnessPal, an app I use every day to record what kind of food I eat. And I've recorded maybe about 1,400 days worth of data, now all available on the dark web. So if you want to know what I eat, you can find out and make trends from it. But this is also maybe kind of bad because if you were my insurance provider, you may say that I eat unhealthily and now increase my rates. Singapore Health had over 1.5 billion patient records leaked, and part of the leak from Singapore Health also included HIV status. And nowadays, while HIV is extremely manageable, there are some countries that will discriminate against you from ever entering said country, which is why the US authorities, CIFAS, basically said recently to a Chinese company that owns the most popular gay dating app called Grindr to sell the company to a non-Chinese entity. Equifax, if you're in the US, they keep credit score data. They have all your data available on the internet as well, fully leaked. And if you like to fly a lot, British Airways, Cathay Pacific, plenty of loyalty information. Maybe you know I like to sit in an aisle seat, all available on the dark web. But the reason why breaches are bad is because you usually end up having to pay a fine when a breach has occurred. There are so many things you need to keep safe, like PCI data needs to be kept safe. That's basically keeping your credit card data well masked. If you're in the healthcare industry, HIPAA makes you also keep it well masked. In Europe, GDPR is a big deal. It's been around for a little over a year now, and the cost of compliance is quite high, and the cost of a breach is a huge chunk of your profits. And every country tends to have their own little data protection acts and privacy acts. So you really need to continuously monitor, make sure you're protecting your data, so encrypting at rest, ensuring MySQL users are well privileged. You need to make sure the data you're retaining is not data you should not be retaining. You also need to make sure that you have backups you are able to delete from those backups, including user activity, and also audit data. So to secure your databases, you really need to focus on the assessments, prevention, detection, and the recovery. Not if you have a breach, but most likely when you have a breach. So, in assessments, we obviously locate risks, vulnerabilities to prevent. We can use things like cryptography, user access controls, all very standard in MySQL and MariaDB now. To detect, you can run audits, you can monitor, you can have alerts. Recovery, you want to make sure your service is uninterrupted. You have forensic logs, audit logs typically. So today, a lot of that revolves around authentication, authorization, encryption, firewalls, as well as audits. Historically, MySQL defaults were extremely poor. You didn't even have a password for the root user. There was no password for the super user account. You entered a password into the shell, it would actually be recorded even on the history. So if you type mysql-u-username-p password, you can always go to .bash history and pick up the password. This is not very good. And of course, don't forget that the MySQL history can also save passwords. So .mysql history. So there are many ways you could sort of defy security in MySQL. There are also signs of poor security. Old Passwords is a plugin that was thankfully removed in MySQL for quite a few releases, but for compatibility reasons still exists in MariaDB. Now you should not use it, naturally, and if you happen to still run old MySQL 3.23 database, it's maybe time to migrate it to MariaDB and switch those passwords. Of course, things like anonymous users, root users without a password, and so forth. There are many signs of poor security. The internet is famous for saying disable SELinux and start running. Don't disable SELinux. Every vendor, being MySQL, MariaDB, Percona, spends time making SELinux contexts ready for you to make it actually just work out of the box if you install a package. And if the vendor is spending time to do this for you, it seems rather silly for you to disable it. Trust-based security. In databases like Postgres, they call it trust authentication, which you can enable for local connections via socket authentication. MySQL has the ability to do this via SOAP peercred, but MariaDB has taken this a little further and actually enabled it by default. When you specify trust authentication, anyone who can connect to the server is more or less authorized to access the database with whatever database username they specify, even superuser name, so to speak. Restrictions made in the database and user columns, of course, will still apply. This really is something you only use, I'd say, for a local system, but not for a system you're going to access over a network. And there are a bunch of interesting references around socket-based pluggable authentication. And on a multi-user machine, you definitely do not want to just restrict access against a Unix domain socket file. So even MariaDB, with its latest 10.4 release, actually tells you that you can actually disable this method. And in my opinion, if you're installing MariaDB for the first time, I think this is easy because it means you get started immediately. You just need to type MySQL and magically it works. But if you're going to configure a multi-user system, I would probably disable this. Now, password snooping. So, Old Passwords is a plugin that I told you you should not be using any longer. And then there's MySQL native password, which was the default from since 5.5 till today. In fact, MySQL native password is still the default inside of MariaDB. But MySQL changed that recently to caching SHA-2 password in MySQL 8. And they've also backported it to MySQL 5.7. But it's not the default in 5.7. MariaDB Server has something else instead of caching SHA-2 password. They have implemented ED25519, which is the elliptical curve digital signature algorithm. Now this means that there are differences between caching SHA-2 password and ED25519. If you have a MySQL 8 instance using caching SHA-2 password, if you're going to migrate that to MariaDB, all the user passwords are going to have to be recreated. MariaDB's C connector does support caching SHA-2 password, which means that you can build libraries against the C connector and connect easily, but the server itself underlying does not support it. And this is of course true the other way as well. If you install MariaDB 10.4, you decide to use add 25519 or even 10.3, then you want to go back to MySQL, you'll have to recreate passwords. So there are many ways for someone to give you a password-based attack. The easiest way is of course a weak password, like hello Barcelona. That is an extremely weak password. It's like a dictionary word you can crack fairly easily. Reusing old passwords. So if I tell you to maybe change your password every 6 months and you go from hello Barcelona to hello Barcelona 1, 6 months later you go to hello Barcelona 2, kind of bad also. Brute force password attacks. This is something that you could totally do with MySQL, of course. And MariaDB Server, I'm glad to say actually in 10.4, which literally got released yesterday, has actually made great improvements and strides in this as well. And we're going to talk about some of the new features. And MySQL 8, of course, was released a while ago and sort of led the way here. Now, network operations. If you replicate within this room, for example, maybe you can replicate regularly without SSL. But most likely you're replicating in a data center, you're replicating in some kind of cloud environment. Replication, by the way, if you look at it, it's all plain text. Easy to snoop on. You definitely want to run with SSL. I wouldn't just say prefer SSL, I'd say require the use of SSL and make sure you have a good certificate authority as well. MySQL 8, for what it is worth, by default, turns on SSL-based connections. You also want to protect against data theft from a high level. You want to encrypt your disk volume potentially, and this is something you can do via LUKS, de-encrypt, and so forth. But there's always performance hit when you start doing that, and typically people who do that tend to need maybe something like HIPAA compliance. So MariaDB Server as well as MySQL have data at rest encryption available for you. However, if you use a Galera cluster, for example, the Gcache portion of it is still kind of unencrypted. And that is the one thing that is getting fixed, but soon. MySQL, and of course MariaDB, keeps on improving as versions go by. So MySQL now, I calculated not long ago, is just a little over 24 years old. It started in May 95, and we are now in 2019. MariaDB is like maybe nine years old. So these servers have just kept on improving, and you keep on getting new features, right? So the ability to do roles recently appeared, for example, in both MySQL, but appeared earlier in MariaDB. Now, mysql.user is a table that people tend to look at because you have scripts that run against mysql.user. Now, mysql.user inside of MariaDB 10.4 is no longer just a table, it is a view against another table called MySQL global privs. So that is a useful change to think about, because this now makes it even more different from MySQL. And MySQL keeps on adding things as well, like creating role privileges, dropping role privileges, the ability to show if the account is locked or unlocked, and so forth. Now, earlier, 2 slides ago, I showed you some user-level functionality that you could see, and you could create roles, show the creative user, and so forth. But we also get key security features by versions, and they tend to be quite interesting. For example, Percona Server brought us the Vault plugin. What is the Vault plugin? It basically allows you to encrypt and authenticate against Vault, which is open source, as a key server. And that is something you don't get elsewhere. Now, MariaDB has a key server as well that goes against Amazon's key management service. But then you have to pay Amazon. But Vault you can set up yourself. We also see things like MariaDB throwing in things like user limits, for example, and roles that came into MariaDB first. And 5.5 brought us pluggable authentication, which is why all authentication is pluggable today, and so forth. So MySQL, as it has evolved from 5.7, made sure that when you set up, you gotta make sure that the root user will have a password. Basically 5.7 would create one that would just throw it into the log file, and it would be a one-time use password that you had to change. But it was kind of unfriendly because you had to grab the log file to find the password. And things like anonymous users were removed in 5.7 as well. Now, I told you that passwords in MySQL and MariaDB are stored as plugins. In this particular instance, which is 5.5, you will realize that it doesn't say anything about a password plugin, and the auth string is basically null. In 5.6, you will notice that the plugin is now filled up saying, hey, you're using MySQL native password. This is the plugin that you use for authentication, and it is specified. 5.7 actually goes a little further, because you'll notice that I'm no longer selecting a password field any longer. I'm talking about the authentication string. So MySQL was willing to, from 5.6 to 5.7, maybe potentially break all your scripts that had to refer to the MySQL user table password, as opposed to an authentication string. And in this case, the authentication string tells you, again, you're using MySQL native password. And MySQL 8 took it one level further by saying, hey, you are using MySQL native password for some users, but these are just some of the system users. In reality, most users by default now will use something called caching SHA-2 password, which is the new default that MySQL 8 wants you to use instead of MySQL native password. There is also, since the 5.7s, a minimum password policy. So I've decided to use the example here where we could just say, alter user identified by, say, Percona, and then if the password policy is low, it'll allow said password, and you can increase the password policy requirements to basically say you need more complex passwords. So an example could be Hola Barcelona 123 bang. As an example, you could also validate password strength inside of MySQL. You could do select validate password strength. For example, in this case, Galera, which says it's 25. 25 would be a low threshold, whereas if we do Galera.123, 100 would be a high threshold. Now this is a MySQL-ism. MySQL's password policy does state that that kind of password is considered a good password. But you and I both know that this is potentially not a good password. And if you later on go to use something like MariaDB, it has something called the cracklet password check, which can actually run it against cracklet. But MySQL does allow this, and this particular SQL function is a MySQL-ism only. It is not in MariaDB. And you can, of course, do show global variables like validate, and it will actually show you what the current password policy is and what is required. So the password length in this case is 8. It requires mixed case and number as well. So, as I said, this is the MySQL native password format, which people tend to do select password as password. And this is actually deprecated inside of MySQL 5.7 and 8. It was removed as well. This, the good news is this actually still works in MariaDB. In fact, this also works now for ed 25519 in 10.4. So general security hardening practices is make sure your root user obviously has a password and so forth. Remove the test database. The good news is, you don't have to think about this. You just need to run something called MySQL secure installation after you've installed MySQL. How many of you do this? Okay. I expect more people to run MySQL secure installation because literally it's there. Maybe it should be run automatically, I don't know. So password expiration is also something that MySQL introduced. And basically in this case, I've created a user identified by a password. I've altered saying the password is going to expire. And after that, it'll actually tell you, you must reset your password using the author-user statement before executing any statements. So if you're actually connected, you can actually reset said password. MySQL 5.7 gave us that password expiry, as well as the fact that you could set a default password lifetime. So you could actually state all passwords expire after 180, which equals to 6 months. You can also require passwords to be changed every n days, where it will expire. You can also, of course, lock and unlock accounts as and when you feel like it. MySQL 8 brought us the ability to ensure that it also keeps a password history, and it's a either global or a per account basis. And because it can keep a password history, it can also ensure that the new password that you're requiring is not the same as an old password. That is, I think, quite useful. You can also require the old password before you get the new password. So if you are familiar with Linux and you try to change your password, you type PSSWD, it'll ask you for your current Unix password and your new password. And you can also set password retry rules as well, so to ensure people don't retry things too often. MariaDB has taken a bit of a different angle to doing passwords. They actually have a password validation plugin, and unlike MySQL, you can chain load password plugins. And what that means is you can actually load simple password check, and in this case, it can basically ensure that you have a number of uppercase, lowercase, digits, and punctuation characters. So hola, Barcelona, all the O's replaced with 0 would actually work with a full stop as a password. Cracklib, password check, you can chain load, as I said. You can have the second one to actually run it against libpam's cracklib, and if libpam's cracklib can crack it, then the password gets rejected. So I consider this to be a little bit more interesting in terms of implementation, because MariaDB chain load stuff, you can actually have more than one password validation plugin. 10.4 also brings the ability for you to chain load authentication options. So remember earlier at the start I said, by default, a user installing MariaDB 10.4 will get socket authentication. You can also now specify that that user can also be authenticated, say, via PAN, authenticated via add25519. Each and every user can have multiple authentication methods. This is kind of unprecedented in the MySQL world, where you can only have one. So MariaDB is actually doing something kind of interesting here, because you can maybe have socket off, and you can also maybe have the ability to do PAN, but if your PAN server is down, you can still log into MariaDB. Kind of cool. MariaDB now gives you the ability to expire a user password. Good, just like MySQL. It also gives you the ability to lock and unlock an account. Good, also just like MySQL. As I mentioned earlier, everything related to authentication is now in the MySQL global priv table, and the MySQL user table is still there because MariaDB cares about backwards compatibility tremendously. It is a view on MySQL global priv. And MySQL global priv, if you take a look closer, is actually very JSON formatted as well. So it's quite easy for people to consume this now. You can also do the set password, which I told you earlier, for add25519. And maybe the most interesting thing I have noted with MariaDB 10.4 is the ability to reload SSL certificates without restarting your server. Now, if you are a web hosting company and you have multiple domains with SSL, and then there's a reason to update the SSL server, you don't want to load the SSL manually and then restart the server. You should be able to just do flush SSL, and magically, it just works. And that's something that many people have wanted in MySQL for a long time. I've seen support requests for this, and I'm glad MariaDB has implemented this. When you install MySQL 8, this is what you will see now as a message. It will tell you that MySQL 8's authentication is new. It is using a strong password encryption, caching SHA-2 password by default. You have the ability to go and use the old legacy authentication methods. Now, when you go and use this, it is worth noting that even just about a month ago, I think Lafred had to write a blog post about how you could use the Perl connector with caching SHA-2 password, or maybe it was the Go connector. So basically any connector that isn't run by or owned by Oracle and maintained by Oracle may require some work to use caching SHA-2 password. But of course the native password stuff still works. So earlier I already said you want to use SSL, and you want to make sure that not just for replication you're using SSL, but also for client connections. SSL has been around for a relatively long time, and if you don't believe that running SSL is a good idea, let me give you a little example. So if you connect via a regular, so I use something called ngrep, which you can get on Linux, and you just type select unencrypted. You will see that this is happening literally over the wire. I can see what's going on. That means I can also see things like passwords and so forth all across the wire. Now in 5.7, it is by default encrypted because SSL has been turned on, and you actually have to go out of your way to turn it off. This is much better. And if you choose to turn off SSL for whatever reason, you will then go back again and see what was available, which is select SSL equals 0 unencrypted, and then you can see everything in plain text again. This alone should scare you to make sure that you go and run SSL-based replication and connections, because otherwise everything's in plain text. How many of you connect to your Amazon RDS from your local host? You type mysql-h some RDS thing. No SSL, no good. Here's some SSL system variables. They keep on changing, of course. 5.6 shorter, 5.7 longer, and 8.0 longest, because MySQL is making it more and more secure out of the box. Configuring SSL is relatively easy. You need to put this in your MySQLD. You need to make sure you have the right SSL version as well as ciphers. This one can get a little confusing because TLS version 1.2 is deprecated. Suddenly you got version 1.3. How are you supposed to know what's the difference? So again, the docs are useful. MySQL makes it a little easier in the sense that you have this tool called MySQL SSL RSA setup from 5.7 onwards, which will ensure that you don't have to use OpenSSL, do all this configuration stuff manually. You just need to run MySQL SSL RSA setup, and it sets it up automatically for you from the command line. This is huge. I'm sure some of you are probably using the cloud, and I've chosen Rackspace, Amazon, and Google here, which tells you actually how you can start using SSL when you're connecting stuff in the cloud. I highly recommend you turn SSL on. Here's an example of SHA-2 password or caching SHA-2 password. In this case, we just pulled up, it'll tell you what the plugin is, and then the authentication string is also quite long. PAM, pluggable authentication module. There are 3 PAM plugins that exist in the MySQL world today. One is commercial, 2 are open source. You should be able to use the MariaDB PAM auth plugin on MySQL and vice versa. You can configure PAM if you want to do a demo real quick. This is something you can do. The reason why I say don't do this in production is because I'm basically adding MySQL to the shadow user group, which basically means I've given MySQL root privileges. Not a good idea, naturally, but this is the easiest way to get started. And actually, you'll have a PAM policy. If you're going to install the PAM plugin, you just need to do this. It is, again, relatively easy. You just install the plugin, and then you select that the plugin does exist. Here's a quick demo of it. Basically, I've created a user identified with auth PAM. I made sure that that user exists on the Linux system as well. And then when I connect, it'll tell me, hey, you are able to connect, and you're connecting via auth PAM. Auth PAM means you have to have the ability to have these people in PAM. Typically, Linux uses PAM as a default. You can, of course, also connect PAM via PAN LDAP to an LDAP backend, also relatively easily. MariaDB also comes with ED 25519 authentication. Again, relatively easy for you to configure. You'll start realizing that this is similar again to Unix socket authentication in MariaDB. Basically creating users and you just have to specify what auth plugin you're going to use. Auditing is another fairly important part of using MySQL and keeping it secure. And there are 4 types of audit plugins available for the MySQL ecosystem. McAfee was the first to come up with it, they still maintain it, followed by MySQL Enterprise, so it's a commercial plugin. And then shortly thereafter, both Percona and MariaDB came up with audit plugin options. MariaDB's audit plugin actually also works with MySQL. In fact, if you go to Amazon and you choose to use RDS or Aurora, and then you say, I want in the option group to have the ability to audit, it will actually install the MariaDB audit plugin for MySQL or MariaDB. Audit's kind of easy, you gotta install it first, then you configure it, and then the log format. Now there are a bunch of log formats. In this case, there are the old and new log format, which is basically XML. How many people read XML and like it? Anybody? Probably not. Which is why we also have the JSON and CSV format. CSV is easy to parse. JSON is the new hotness, for at least since people hate XML. So the audit plugin can give you XML in 2 formats as well as JSON and CSV, which makes it relatively easy for one to use. Of course, this is applicable for the MySQL audit plugin as well as the Percona audit plugin. MariaDB chose to do it a little differently. They don't give you the option of having multiple formats, but you just get a CSV format, which is fine. You don't need JSON. Now, MariaDB also extended the audit API, so you can do user filtering, which is quite nice. So you can filter by user. Percona has managed to actually do filter by user in the audit plugin without extending the audit API. And because Percona is interested in performance, they also have the ability to audit in an asynchronous fashion, a synchronous fashion, or a semi-synchronous fashion. And of course, as you would know, auditing does add some load to the server, maybe, a couple % extra load. MySQL Enterprise Audit actually includes a utility in the MySQL utilities package called MySQL Audit Grab. This allows you to grab the audit logs, and you can use MySQL Audit Grab even if you get the audit logs outside of the Percona audit plugin. So we move on to secure storage. Encrypting your data at rest is extremely important. There is a good chance that all your laptops have encryption on it already. If you use Linux, it tends to use dencrypt when you start setting it up. If you use Mac OS, it comes in FileVault. If you use Windows, I don't know, I don't use Windows. And key management is also quite important because you want to be able to have an external key server. So keeping everything encrypted, and if you keep the encryption key on the file system, if someone breaks in, they can walk away with it and decrypt all their data. That's exactly what has happened with many other systems which are obviously not encrypted. However, if you keep external key management server, if someone breaks in, they also have to break into the key management server, and that's much harder. So MariaDB actually brought the encryption first. It is actually contributed by Google and another company called EXPIRE. So they do table level encryption, but tablespace encryption came to MariaDB from Google. And you can also obviously encrypt your temporary files, binary logs, relay logs, and so forth. Encryption in MariaDB is fairly easy to set up. In fact, it's super easy to set up because MariaDB includes a preset. It's under your my.cnf, the d-enable encryption.preset. That means you just need to put that in your my.cnf, and automatically you will be running a fully encrypted server. The plugin is available for Amazon Key Management Service, which means you do need to pay Amazon to unlock stuff. MySQL Binlog, of course, does not have a way to decrypt an encrypted binary log, but because it can do streaming backup, you can actually use that as a way to decrypt an encrypted binary log. Gcache as I said, is the encryption for it in MariaDB Server actually is ready. And MariaDB backup for encryption is a good idea. You can't use extra backup anymore either. You have to use Maria backup. So if you're using MariaDB, no more Percona extra backup. It's all Maria backup and backported all the way even to 10.2. MySQL introduced InnoDB table space encryption, and initially in 5.7 they did not support general table space, system table space, undo logs, as well as temporary table space encryption. This obviously got fixed in MySQL 8. And data is encrypted for the redo, undo, binary logs as well. The external key management solution for MySQL 8 is the Oracle Key Vault. I do not know how much that costs. It's probably a lot of money. So naturally, key management, of course, got improved tremendously as time goes by. MySQL also offers an Amazon key management service, very much like MariaDB has offered for a very long time in the enterprise offering. So the best credible alternative, if you don't want to use Amazon, is probably the Vault plugin that is available. Encryption, of course, really only works with InnoDB. The KMS is quite kind of nice to use. You can obviously use other things like Lux and so forth. Now, when you use Galera Cluster, for example, you want to make sure you secure the network. That means turn on SELinux, but also make sure you have IP tables. You're opening up a bunch more ports. Don't just say, go ahead and don't have anything. You want to encrypt your Galera traffic. In fact, when you use MariaDB Galera Cluster, it is actually configured to make sure it's running in an encrypted fashion. Turn on table space encryption as well. And you can do a full state snapshot transfer in an encrypted format as well. SQL standard roles have been in MariaDB first, and then came with the ability to create a default role shortly thereafter, and also appeared inside of MySQL in 8. And basically a role is a user account with the login disabled. It is a memory-based hash of flattened privileges that exist for each and every active role. Roles can also have an optional host, and users can have several roles. So you could put a user into a role that says that one of them is an accountant, the other one is a CEO, the other one's in engineering, and so forth. It's worth noting that MySQL 8 introduces new tables for this, the role ages and the default roles. A couple of new functions, including the ability to do things like role graph ML. That means you get a graph ML output of roles. This is not in MariaDB, this is a MySQL only thing. But everything else is more or less the same as in both, because roles really are an SQL standard. Data masking. Data masking basically is the idea that you want to substitute values, real values, with something else. Basically, this is a great way to store credit card details maybe. MySQL actually has the ability to data mask inside of MySQL, but you got to pay money for the enterprise version. So the poor man's substitute for data masking, and there are some good talks that you can go refer to. Proxy SQL does data masking as a proxy, from a proxy layer of the data that's stored in MySQL. MariaDB MaxScale also does data masking. There is a wonderful plugin for data masking available. The only caveat you should note about MaxScale is that it comes with an interesting license that is not open source. 8.0 also has a few other interesting things, like the ability to have atomic ACLs that stay inside of the InnoDB data dictionary. Now, that's kind of interesting. The ability to do dynamic privileges, so you can actually add, revoke, and as well as check privileges. So you can just say, this user at runtime is going to get a few added privileges. This is a 8.0 only feature. Firewalls. MySQL Enterprise, of course, comes with a firewall. You can pay Oracle for this and use it. But the other options are use proxy SQL, which also has a firewall available, and MaxScale. What is firewall good for? It's going to probably help you prevent against SQL injections, which are, I guess, kind of common if you're not using a modern framework I mean, PHP for the longest time has the ability to disable this, but if you're using old code, then maybe you benefit from a firewall. So, today I talked to you a lot about authentication, authorization, encryption, firewall, auditing, and I've only just touched the surface because you can't really go deep for a 40-minute talk. There is a lot that we can also talk about around audits, the ability to redact logs. So, the audit plugin in MariaDB, earlier releases used to actually also audit and save the passwords, and that's been removed, for example. Also talked about external authentication. I did not once mention the ability for you to connect via Kerberos. MariaDB has the ability to do Kerberos, GSS API or SSPI, which is Active Directory. MySQL also has Active Directory, but enterprise only. SSL is really, really good idea, in my opinion. The ability to do encryption and key management, and I think there's a lot more you can do with key management going forward, because you shouldn't only be limited to having Vault or AWS KMS. I can only recommend you to regularly upgrade and use new software because it gets fixed. Things get fixed all the time. One quick thing is that I touched the surface again for security, but there are MariaDB Server certification tests that are happening in like 10 minutes. And if you go in 10 minutes, you can walk away with the certificate, assuming you pass, in a couple hours, which is nice actually, because this is the first time it's being run in Europe. Otherwise, you normally have to go to New York in winter or towards the end of winter in February. And hey, it's sunny Barcelona. What would you do before now and Cerveza time? You would go get certified. Also, I did mention you could win some raffle, like headphones maybe. So maybe take a photo of that thing or visit the Galera Cluster booth. With that, thank you for listening. And if you have any questions, I'm happy to try to answer them. If you don't, thank you.